Hey guys, today I'm going to talk about habitat fragmentation. More specifically, the effect habitat fragmentation caused by roads and shipping routes has on migration patterns and populations. But first, what is habitat fragmentation? Habitat fragmentation is when a large expanse of habitat is turned into smaller patches. This can affect continuity of resources, genetic variation, and movement pattern of animals. Habitat fragmentation usually occurs naturally on Earth through the formations of rivers or mountains, which can take millions of years, or through lava flows, which can happen much faster. Man-made habitat fragmentation happens much faster, giving animals less time to evolve and adapt to changes in their habitat. As we will see, habitat fragmentation has a myriad of implications on the populations that they affect. But first, let's go over some basic terms. Road ecology framework is the idea that roads affect the habitats around them. This framework looks at the impact of roads in four ways: physical disturbances, modification of animal behavior, chemical pollution, and the actual fragmentation of the land. Next, let's look at transition zones. Transition zones are where two biomes or habitats meet or integrate with one another. It may contain features from both habitats and processes from both ecosystems. Some examples of this include marshlands, which integrate between dry and wet ecosystems, grasslands, which integrate between forests and deserts, or estuaries, which integrate between salt and freshwater. As we learned in class, these transition zones or ecotones act as their own habitats and have small, numerous ecosystems. Okay then, now let's discuss the academic literature regarding habitat fragmentation and the effect that it has on the animals residing in those habitats. As mentioned, habitat fragmentation can lead to a loss in genetic diversity. Irene Keller from the University of Switzerland wanted to study the effect habitat fragmentation caused by roads would have on ground beetles. As the name implies, ground beetles cannot fly. Keller studied the beetles in a Swiss forest that was fragmented by numerous roads and a highway. Her goal was to look at the genetic variability in gene flow of different populations in the different fragments. She then compared the different populations based on the number of roads in between the different fragments. Ground beetles themselves are able to cover roughly 10 meters in 24-hour span. For reference, roads are roughly 6 meters wide, so it takes a considerable amount of time for a beetle to cross a road. While they do cross, they are at a high risk of collision from oncoming traffic. A comparison of allelic richness showed that genetic variability in the fragments closest to the highway were different from the rest of the study group. An allele is a different form of a gene. Most genes have two alleles, a dominant and a recessive. The findings on genetic variability show that roads are an absolute barrier to gene flow in the beetle population. In addition, it showed that population isolation can cause inbreeding and loss of genetic diversity. Genetic diversity is essential to a long-term population's growth. Another study done by the University of Oklahoma wanted to look at the effect habitat fragmentation caused by roads, fences, and electrical lines had on the prairie chicken populations. They looked at two separate populations, one in Oklahoma and New Mexico. The population in Oklahoma was much more exposed to habitat fragmentation through roads, electrical lines, and fences, while the population in New Mexico was less fragmented and much more free range. In order to track them, researchers placed radio tracking bands around the ankles. Survivorship curves were then created based on the mortality rates of the chickens. From there, they were able to estimate the probability of population persistence based on a population model. The researchers found that the primary cause of death in the Oklahoma population was collisions by cars, whereas in New Mexico it was typically predation. In fact, Oklahoma chickens were 3 times more likely to die from collision compared to New Mexico chickens. Another key finding was that the Oklahoma population re-nested 5 times more often in a given season due to adaptive pressure. The birds had nearly 50 generations to respond to environmental differences, and changes in life history could be seen after 20 generations. These ramifications were very telling to the researchers. In fact, they predicted that the Oklahoma population would probably go extinct within the next 30 years. Habitat fragmentation can also occur in aquatic systems, not just terrestrial systems. Shipping routes in the ocean are fairly analogous to terrestrial roads in that they concentrate the movement of vessels from one location to another. For some background, shipping is one of the world's largest industry, accounting for nearly 80% of merchandise trade. Researchers from the Ecological Society of America looked at the effect of shipping had on marine life using the road ecology framework previously discussed. It specifically focused on larger marine life, like whales. Ships are getting larger and larger every year in order to accommodate for global trade demand and produce oil pollutants, air pollution, and greenhouse gas emissions. Marine giants such as whales are more relatively impacted by ships because they have numerous surface actions, such as breathing or basking. They also provide essential ecological roles, such as the transference of nutrients and biomass to deep-sea environments, and whale falls. Whale falls are when the dead carcass of a whale descends to the bottom of the ocean and acts as food for different animals at different ocean levels. Whales are capable of traveling large distances, and their migratory paths typically intersect numerous shipping routes. Applying the road ecology framework, we can see that ships are very likely to hit and collide with whales, causing the loss of a whale in a small and vulnerable population. In addition, communications that ships use and the noises that they create affect the low-frequency communication and vocalization that marine life used to communicate with one another. Chemical pollution from ships causes changes in ocean chemistry, which may affect the seasonal movements to coincide with feeding grounds that may not have bloomed yet. Arctic shipping also creates fragmentation, physically splitting the land and affecting polar species. There are numerous ways to mitigate these effects, however. Relocation of shipping lanes would be a key way in preventing future collisions between ships and whales. Researchers at the University of Thessaloniki, Greece conducted research to see how its change in shipping routes would prevent collisions with sperm whales specifically. The Mediterranean sperm whale is an endangered species whose core habitat centers around the Hellenic Trench. Many major shipping routes run on or along the Hellenic Trench, causing an unsustainable amount of collisions for the sperm whale. The researchers used sperm whale sighting and density data, as well as data on the vessel traffic in an area to estimate the chance of collision between a sperm whale and a ship. The researchers found that a 70% reduction in ship and whale collisions could be achieved by only rerouting routes about 11 nautical miles, with most routes only being rerouted 5 nautical miles. This rerouting would also affect numerous other species, such as the Coover's beaked whale, monk seals, and logger-headed turtles. These animals would also benefit from reduced noise, as well as reduce the risk of oil spills reaching the coast of Greece, which is an important tourist destination. Aquatic habitat fragmentation can occur in more than just the ocean, but also our rivers. Stephen Schmutz and Jan Senmir explore this concept in their book, Riverine Ecosystem Management. The primary source of river fragmentation is through dams. There are more than 58,000 dams globally, and these dams fragment nearly 60% of all rivers. In places like Europe, where dams are much more ubiquitous, only 20% of rivers remain free-flowing. These dams are used for hydroelectric energy, flood control, irrigation, and as a water supply. Dams limit fish migration patterns, however, causing a loss in aquatic biodiversity. Nearly 37% of fish are threatened, and nearly 4% of Europe's fish are near extinction. This is the highest threat level for any taxonomic group. Dams interfere with fish migration patterns by altering water depth and water velocity. A major problem with dams from an ecological standpoint is from the metrics used to measure their ecological impact. Currently, dam density is measured by number of dams per river system or number of dams between two geological barriers. These metrics, however, are too vague and make it difficult to measure the true ecological impact on a river system. There has been a shift to the Dendritic Connectivity System, or DCI for short. DCI shows the relationship between the number of river fragments, the length of the river, and the length of the entire river network. What DCI fails to account for, however, is that it assumes that the entire river network is equally important and neglects the fact that some areas of a river are more prone to fragmentation than others. For example, berries closer to a river's mouth affect the entire catchment upstream, while dams and headwaters only make small proportions of a river inaccessible. Therefore, a new metric, the River Migration Connectivity Index, or RMCI, is starting to be used. This metric proportionally weights river volume and class, and also incorporates the proportion of migratory species visiting that river fragment. As we can see, habitat fragmentation has serious implications. It affects animals and ecosystems at a very deep level, and serious changes must be made in order to prevent future effects on the animals that reside in habitats. Numerous animals, such as birds and insects, are studied to determine the effects of climate change and measure changes in the Earth's atmosphere, so their preservation is essential. As a whole, though, each animal is essential in their own way, and we must do whatever we can to ensure that no further harm takes place. Thank you.